All right, so I'm not totally comfortable putting this out there. I am about to start something, and number one, I don't know if I can accomplish it. Number two, I don't completely know all the steps along the way. I don't even know what I don't know, so that makes it a little bit more difficult. But I'm going to do it anyway, because I think the journey is worth the recording. So I'm going to put this out here on this channel, and I'm going to do my very best. So when I started the Iron Man project, the heads-up display and all, I don't believe I ever had any intention on trying to fly like Iron Man. Not usually the daredevil. I'm the computer science guy, the programming guy, the electronics guy. Keeps me down on Earth, keeps me relatively safe. I'm just at a different spot now. I always like to push the limits. I always like to do things that people haven't done before. That's always kind of been like the first line on my resume. I feel like this is something I need to at least attempt, at least play with, at least see how far I can take it. So that's what this video is. This is part one. I'm gonna keep working on the heads-up display because that's part of the bigger picture. All these little videos I'm gonna make on the side are all part of the bigger picture. They're part of me learning, and they're part of me bringing everything into myself about what I need to know to accomplish my goals. So that's what this is. I have always wanted to learn all about remote control aircraft. Just RC in general has always fascinated me. I loved it when I was a kid. I loved remote control cars. I like drones, but I've never actually owned one myself. So I have little to no experience with RC, with drones, with flying machines. Again, a little experience. I definitely have a theoretical knowledge of these things. I've played with an EDF once in a project I worked on. You know, and I know electronics, and I know electricity and how all this stuff plugs together. So I'm not coming at it blind, but the project itself is definitely outside my comfort zone. So let's just jump into this. So the first step in this whole process was me ordering the parts I needed to learn how to do this. This is how I learn. Sure, I research, sure, I go online and study as much as I can from other YouTubers, from just theoretical knowledge, just learning the mechanics. I do all of that. But I don't find I really learn something until I get it in my hand and I actually start messing with it. And so that's what I did. I ordered an EDF, which is this electric ducted fan. It is a fan that is ducted. It has attached to it what's called an ESC, which is an electric or electronic speed controller. This one's a 40 amp, which is how big this motor is. And I also ordered this, which is an RC controller. And this came with a already paired 2.4 gigahertz receiver. I said, well, this is how I'm going to learn. I'm going to hook all of these things up and I'm going to see how they work. And I just started tinkering. I already know that one thing, EDFs are extremely dangerous. They can cut fingers off, they can hurt you, they can fly off into your face and cut your nose from your face, and that would be bad. I also took my knowledge of CAD and I designed a very simple, kind of like a Mars lander, if you will, just to contain it so that I could play with it from afar and not worry about getting hurt. So this part I've already done. If you've been following me, I've played with it. And for anyone who thought I was just out of my mind and didn't know what I was doing, and I thought, you know, whatever you thought about it, I knew what I was doing. It's not going to fly like this, folks. Number one, it's extremely difficult to design anything with a single EDF because the rotational forces will make this spin just because you only have one motor and it's spinning, and it's very difficult to counteract that spinning. You can do it, but it's very difficult. Also, it's almost impossible to balance a single EDF because where are you going to put all this? If you saw that video, I was putting it underneath it. Of course I was putting it underneath it. It's the only possible place I could put it to give it a little bit of balance. But I knew it was in the way of the fan people. I mean, duh. This was just to experiment with. But anyway, this works, it connects. I have a battery. I had a bigger battery when I was playing with just this, but I bought some smaller ones since then. And this works. It allowed me to test out my radio controller. It allowed me to test out the EDF, the ESC, the receiver, and now I know more than I did before about how all of these things work together. So this was step one. Now it's time for step two. And step two is actually building something that should be able to hover on its own. Now, why do I say hover and not fly? Well, in order to build a craft, a drone that can fly, it needs a lot more smarts. It needs a flight control computer that knows how to power certain motors up, how to balance itself if something happens, how to account for one motor or one battery being slightly less than the other. There's a lot of smarts that go into a flight controller. I'm going to build just what I'm calling a hover bot. And that is something that, from a physics perspective, I believe should be able to hover, just go up and down. You know, I'm not going to take it too far off the ground because without a flight computer, there's nothing really to make sure that it's staying balanced. We're all relying on physics and things working pretty much perfectly for it to work. We're going to build a hover bot. And for this, I need 4 motors, 2 of them that are going to spin clockwise and 2 of them that are going to spin counterclockwise. So that's what I have right here. That's step one. And then each one of those is going to need its own speed controller. We're going to need at least a couple of batteries because, number one, I don't want to run 4 motors off of 2 batteries. I think that's a really bad idea. Plus it wouldn't last very long. Plus you have to balance that single battery. This is a little bit easier to balance with 2 batteries. Got some splitters for those batteries to go to each motor. This is a little chintzy and I'm not 100% sure that this is going to work right, but we're gonna find out. This is a 4-way splitter that's going to take the output of my receiver and split it between all 4 of these ESCs. And then we're gonna see if that works. The receiver output here is just the output that you would get to a servo. From what I understand, it is an identical signal. So technically, it should be able to be split. There's not a 2-way communications or anything I have to worry about here. So what did I do? I knew all the pieces I would need. I designed my original bot to be modular. So what you'll see here is I've got a clamp system that goes around the EDF. And then I've got the landing pods. I'm sure they have a name. I'll look it up and I'll probably put it down here on the screen because I'm sure they have a name. But the landing feet. And so I already had this for this one. And then I basically just needed to expand this. This is the whole idea behind this system that I'm creating here is it's modular. You'll notice this thing has multiple mount points all the way around it. So I just went with that and I expanded it. I made 4 of these. So you got 4 of these. I then printed 4 of these. You've got some new corners, or sides I should say. You got some new side pieces, and those are going to go on there. And then we have battery holders, because the batteries kind of need to be secured. And then hexagons. In order for it to fly, you obviously need hexagons. And so I built this really cool plate that goes in the middle, kind of stabilizes the whole structure, and then allows me to pretty much strap down anything to the center of the hoverbot that I need to strap down. So that's what we're going for here. Now I have to assemble it all. So first of all, how did I print this? So all of this was printed on my Flsun V400. All these red parts, all the yellow parts are all printed on the Flsun V400. I'm really loving that printer. It's fantastic, it's fast, it's versatile. I love the fact that it's running Clipper and I can just send files to it so easily. Obviously, yeah, you can do that with other systems as well, but I'm talking about this one. These are all going to be out of ASA, which is an ABS-like material. I figured it would be good and strong. It prints relatively easily on the Flsun because they're not very tall or complex parts. So there we go. That's everything printed. And these guys. These are a freaking challenge because they need to be printed upright like this. And number one, you got to get it to adhere to the bed. And then number 2, you have to get a printer that is as I don't know. I would say well-tuned enough, but all my printers are well-tuned. But I just had to find a printer that would like this. And I printed these 4 legs. I tried to print them on the Flsun, that didn't work right. I tried to print it on my freaking Ender 5, which is my workhorse prototyper that prints almost everything properly. That failed. And then I went over to my Lerdge IX, my little printer that could. So these printed on my Lerdge IX the first freaking time, where other reliable printers among my fleet were failing me. So these 4 were printed on my Lerdge IX out of PLA Pro. And by the way, all that filament is from Polymaker, not sponsored. I bought that filament myself. Just wanted to send a shout out for who I ordered that from. I think it's time for me to stop talking about this and actually get it built. And I freaking cannot wait. I have done a cleanup of these parts. I've got some of the like 5mm screws already embedded in here, but I haven't put all this together and seen it work. So I don't know what's going to happen here. This video is me doing it real time like I've always done on this channel. Let's get this built. I'm gonna stop talking. I know a lot of you are saying you should have already done that a while ago, but while I'm immersed in the world of drone crafting, let's talk about something that can take our projects to the next level. PCBWay, my sponsor. As I work on creating a drone that's worthy of our favorite superhero's legacy, I can't help but to think of all the amazing possibilities PCBWay offers for future projects. I'm already dreaming of 3D printing in exotic materials like industrial resins, nylon, or even metals like aluminum and titanium. Ever thought about CNC machining your drone components in metals or polycarbonate? Picture crafting a drone that's not just a toy but a true marvel of engineering. It's like having access to a genius billionaire's workshop. Looking ahead, custom electronics are on the horizon. Just think I could create specialized components for my drone, making it truly one of a kind. And the best part? PCBWay's incredible pricing and assembly services make it accessible to any aspiring inventor. So whether you're building drones, tinkering with electronics, or exploring the boundaries of technology, remember that PCBWay is your partner in innovation. All right, so at this stage of the game, everything is about balance. This bot is not going to have any intelligence. We're just hovering using the 4 motors we have here. And so balance is very important. So as you can see, everything I'm doing here is symmetrical. This would still be a good design idea even if you did have a flight computer, because you don't want the flight computer to have to overcompensate really. You want it to actually just be able to fly. And so what I've done here I think is pretty good. I've got the ESCs mounted on each of these conveniently geometried places to zip tie things. So I've got those right there. Now what is left, batteries, which we already have a place for the batteries. We then need to get the receiver, which I have to pull off of here, mounted, you know, somewhere in the middle. All of the ESCs go to the receiver, and that goes to the battery. Let's finish it up. Okay, it's done, and the camera's crooked. Okay, so it is done, and this is a heck of a shot because this is just for posterity, and I am being very, very careful with this because I don't want to break anything or screw anything up. So I haven't plugged in the batteries yet. I haven't done anything yet because this is on camera and I want to make sure it's done right. I'm really happy how this one came together. I did find places for all of the wiring. As you saw while I was assembling it, it turned out really well. I'm gonna make sure that all the battery stuff is not going to get in the way. I don't want anything to end up in a motor, because things ending up in a motor is bad for the motor and the electronics. And I think I have everything secure at this point. This is not a real flight, keep in mind. This is just, I want to check it right here on the desk to make sure all of the motors spin, for example. So I haven't plugged in anything. I have to be really careful with this because once I plug it in, something could happen, and I want to make sure it doesn't. I'm going to plug in this one. This goes to 2 motors. Okay, it beeps at me and lets me know that these 2 motors are talking. They are the opposite motors, just like it should be. That's how I wired it. Let's do the other ones. Freaking scary. Because if it goes like totally freaking haywire, I don't know what's going to happen. So far, so good. I didn't blow up the receiver. It's a good sign. And I'm going to step back because I have to turn on the remote. And we're going to see what happens when I do this. This could be really loud. I might need my hearing protection. It's making noises. Now I'm back far enough. Again, I should be doing this outdoors. But you know, what's going to break? Just my whole set, that's all. Let's see what happens. I'm just going to give it a little bit of throttle. Okay, while it sits there, see, this will stay there. I want to make sure they're all 4 spinning, and they are not. This one right here is not spinning for some reason, and I need to figure out why. If I try to lift off right now, well, let me give it a little bit more. There it goes. Its startup was a little bit more than the other motors. So they're all spinning. You know, I want to see what happens when I crank it a little bit. So I was probably at maybe a third of the thrust, at least by the stick. I think it started to lift just a bit. You saw it crawling a little bit. So we definitely have a chance of liftoff there. Let's try it one more time, and then I'll wait till tomorrow. That time all 4 cranked up at the same time, so that's a good sign. So it walks, all 4 motors power up. At least from a theoretical standpoint, it is working the way I expected it to. So I'm gonna wait till tomorrow, because I don't know what's gonna happen if I try to lift off without any sort of flight computer attached that will self-level as it starts to spin up. So I'm gonna leave it right there, as much as it pains me to do so. And I will try this tomorrow. This will give me a chance to charge up both of the batteries and make sure they're at equal charges so that I get equal current delivered to these motors, because that also could be a problem if they're getting different levels. So let me charge these up, and I will see you tomorrow sometime. Success! Oh my God, it worked the first time.
Day 2.
All right, I am out here with nature this morning. It decided to rain on me last night, but it's not raining right now, so I'm gonna go for this first flight. It worked last night. Let's see if I can get it off the ground though. I don't know if it's gonna be balanced enough to actually produce any amount of height without me getting nervous and wanting to take it back down. So let's just see how it goes. All the batteries have been charged, so they should be all at the same charge level. All right, let's see how it does. So about 50% power now. It's not actually lifting yet. All right, so I'm at full power and I'm not getting lift. According to all the math I've done, this should be able to lift up. I've got about 3 kilograms worth of thrust, and I've got about 1 kilogram or so worth of drone. So there should be more than enough power here to lift this drone. The only thing I'm worried about is that the power, that the batteries don't have enough output power to actually feed the EDFs with enough juice to get up to their full ability. So these are only 35C, and I just learned about how C's work. These are only 35C batteries, and I'm wondering if I need to buy the 100C batteries in order to pull enough juice out of them. I'm gonna try this one more time. No harm in trying, but I don't know if I'm gonna get enough lift now. So I do get, if I kind of crank it, I get a little bit of lift, and I'm guessing that may be just how it's pulling current off the batteries. Let me get this, I'm gonna get the camera closer and we'll take a look. I think that's a yes, but it looks like I've already broken an EDF. No, I didn't break an EDF. The screw came undone, which just sucks. I'm a little disappointed in the manufacturers of these EDFs for not cranking that down a little bit more. So I need to fix this before I try anything else. Alright, as you can see, I've moved out to the driveway because I wanted to see if the surface made any difference. I've tightened up all of the motors so that hopefully we won't have that problem again. Let's give it one more shot without having to buy new batteries. Batteries are very, very warm. The ESCs are not warm. The motors are not warm. So yeah, I think I don't think we have enough juice coming out of these batteries at only 35C and trying to pull enough juice for 2 motors.
Day 3.
Alright, so this is round 2 of my EDF drone. I have replaced the batteries with batteries that hopefully will have a lot more juice that they can provide. And they're a little lighter, they don't fit as well, but I'm not going to redesign those battery holders until I know that they're going to work. So let's give this a shot. I'm going to plug it all in, get everything going. We're going to give it a test just like last time, see how it does. Okay. Sounds like we're good. And I still can't get lift off. It looks like I may have to go back to the drawing board because I don't know why I'm not getting lift. There should be plenty of power here. I've already checked all the specs. Battery should be delivering enough juice now, but it's just not lifting. These batteries are even lighter than the other ones. It wants to lift. I even see it lifting off the ground just a little bit. It's like it's holding some of its weight, but it's just not picking itself up. So like last time, we're going to move to the concrete, see if that makes any difference. Okay, so I figured it out. For whatever reason, even though I wired them all the same, 2 of these don't want to be wired that way. And I actually have 2 motors pushing up and 2 motors pushing down. It must have something to do with the fact that some of them are clockwise and some of them are counterclockwise, and I didn't realize that that affected how I was supposed to wire them. So I literally have this drone pushing itself up as hard as it's pushing itself down. It probably means it would have flown with the other batteries I had, and I can try those again So I'm going to double check which two need to be rewired, and I should be able to swap the red and the black wires, and it should make them spin in the other direction. I'm going to double check it, then I'm going to disconnect the batteries, and then I will swap them. So yeah, this one and this one are not blowing down. These two are blowing down. So I need to swap these two. Okay, I figured it out. So 2 of the motors are on one channel now and 2 of the motors on the other. I don't think that that matters for this case, but I actually have been playing with linking channels, so maybe I can play with the trim to get this thing to hover really well. That's not important now. What's important now is what I've done is 2 motors, and I think this is how I wired it to begin with, but I didn't think about it, and I just wanted to make sure I didn't blow anything up because battery fires are bad. So I've got 2 motors, the 2 going clockwise on one battery, and the 2 going counterclockwise on the other battery, and I've reversed their polarities. So I have verified these are all spinning in the right direction now, and so I know that if there's enough thrust here, this will lift. So here we go. That's fine. It doesn't matter. The fact that it lifted is all I care about right this minute. So there is enough thrust. I was only about halfway there and it finally did lift up. So let's try this again. There's a little breeze, which I'm not enjoying, but I may play on linking these and playing with the trimming just a little bit. But let me do it again. Let me move it down because it's running right out of frame here for you. Almost. It seems to want to walk that way, which is fine. There we go. It flies, and I definitely don't give it anywhere near full thrust to do that. So there's some thrust to be given. Cool, right? Very, very cool. Way too easy for it to get caught on this deck. So it's not allowed to kind of just hover along the ground as much as I'd like it to. All right, we are in the front yard. Let's see how it does out. I don't know if this is any better, but we're gonna find out. All right, I'm gonna try something crazy here. I'm gonna move it to the grassy part. Let's move to the grass, and then maybe I'll just crank it to see what happens if it like tries to go up in the air. It could be bad. I could break parts, but that's why I printed these out of ASA, and it's why they're 3D printed to begin with, so I can replace them. Well, let's take a look. Oh man. Well, I got a little dirt in one of the motors, so that'll have to be cleaned out. Other than that, it didn't do too bad. I only broke one landing gear. So, was that it? Found it. All right, cool. that was the extent of it. I got a little dirt in this motor that I need to clean out, and I broke one of the landing gears. Not that bad at all. To do anything more with it, I'll go reprint my landing gear real quick, and I will, I'm not talking to the camera, I'll reprint my landing gear real quick, and I'll clean out that motor. And like I said, maybe I'll run each motor to a different channel, see if I can get them all linked. And then that will let me do a little bit of trimming to see if I can get it to fly up more level. I don't know if it's going to be possible without active controls, but I mean, heck, that's the whole point. Let's keep playing with it. All right, I reprinted the legs on this guy, and they look fantastic now, and they are working again. And I've done a little bit of reconfiguring. So hold on. Okay, so right here, I have ran all 4 motors directly to the receiver so that they can actually be operated independently. And then I've done some magic in the transmitter that actually sets up how they communicate with one another and how they're tied together. There's some pairing that I've done there. And so now each motor is actually controlled independently, or can be. This means there's no splitter underneath the bottom anymore. We've just got the 4 going directly to here. And I think this will work now. Now, technically, this does give me the ability to kind of fly by wire a bit. Like I could technically control them all independently. I think that would take a lot to learn how to do. So there's still going to be a need for a flight controller, but I wanted to play with it. I like this direct connect rather than going through a splitter. So let's give it a shot and see how it does. Also went back to the original batteries to see if they can lift off, and the whole problem was originally what I thought, which was the motor spinning backwards. So let's check it out. Hey, you got a little bit of airtime that time. That was cool. I was actually kind of doing that control independently there, readjusting a little bit just to see what it does. It almost got off the ground pretty well that time. Let me get you closer. I didn't like the sound of that one. Let's see, did I break anything? Nope, I don't believe I broke anything. Oh, fantastic. All right, let's try again. It's easy to flip without a flight controller. Kind of getting warm. Let's see. Yeah, motors are getting a bit warm. All right, back in the garage, got everything back on the table, and I have to say this is an overwhelming success for this part of the build. If this is the extent of broken plastic for some first test flights, then I think I am well ahead of the game. So I'm going to go back to the drawing board. I do want to do, not back to the drawing board, but I'm going to do a little bit of redesign on the parts I have here on the table. We've got some other ideas after flying this a little bit I'd like to give a shot. So I'm going to do a little bit of rearranging, maybe just expanding, have some more options. We've got some larger batteries I'd like to see if it could lift. That'd give us some more flight time when we get to that point. And of course, I've got the flight computer that I'm going to integrate into this next, because I've shown that the idea of really flying a quadcopter without having the computer's intelligence on here, making small adjustments as you're getting off the ground, and particularly as you want to actually go anywhere, is an absolute must. So in the next video, I'm going to show you which flight computer I picked. There wasn't a whole lot behind it, but I can tell you a little bit about that. And thank you all again. Step 1, I learned a little bit about the motor. Step 2, I built a quadcopter in Fusion 360 and flew it after a little bit of debugging, and I kind of showed you all that process along here. My first RC project, my first, honestly, my first time dealing with these motors and ESCs, and it's been a blast. I've really enjoyed it. So I've spent like 3 years on this helmet over here, and so it was really time for me to kind of stretch a little bit and try something new. And I hope you're enjoying this process. If you are enjoying all of this, thank you for watching these videos. Thank you for getting through the end of these videos. You are the best of supporters. If you do like this new format, if you like me not focusing always on 3D printers and instead actually doing things with them, building things, if you like the helmet project, if you like the quadcopter drone project, please consider supporting me on Patreon, kind of like all of these people over here do. These have been fantastic supporters. I wouldn't be doing this if it's not for these guys, because these are getting to be expensive project. Obviously, the helmet was a very expensive project. This is an expensive project, and so all your support is really coming in handy as I go from just a 3D printing channel to an actual maker channel. So thank you for anyone who joins because of this. I really appreciate all of that. And again, hey guys, this is Kersey Fabrications. This is what I always had in mind for the channel. I'm really enjoying making stuff, and I appreciate all your support. Thanks for watching all the way to the end. Take care of each other, and I will see you next time. Thanks for watching.